Imagine you are building a house out of children's blocks and calculating its strength using standard blueprints. But suddenly, the building turns out to be 3 times heavier than all the blocks combined. Yet it stands as if nothing is wrong. How is that possible? Modern astrophysicists faced precisely this puzzle. The James Webb Space Telescope showed us the early universe, an era just a few hundred million years after the Big Bang. And the galaxies there turned out to be so massive that according to the laws of old physics, they simply shouldn't exist. They are far too heavy for their age. But a sensational new study has revealed the universe's main trick. Trillions of invisible hidden stars are lurking inside them. Today on the Shocking Space Channel, we will uncover this mystery. When James Webb first began transmitting the first deep space images back to Earth, scientists were thrilled at first, and then held their heads in disbelief. That's because giant galaxies were found in the oldest corners of the universe, matching the mass and star count of our mature Milky Way. But how did they manage to gather such colossal mass in a mere 500 to 600 million years? The early universe simply didn't have enough time for stars to be born, die, and accumulate into such incredible clusters. Skeptics even claimed that the standard model of cosmology was bursting at the seams and that physics would have to be rewritten from scratch. Astronomers found themselves at a dead end. Either the telescope was wrong, or we fundamentally misunderstood how stars were made at the dawn of time. And then the answer was found. Scientists realized we were making a fatal counting error. When we look at distant galaxies, we judge their mass by the light they emit. More light equals more stars. But in the early universe, the rules of the game were completely different. The first galaxies were literally flooded with incredible amounts of cosmic dust and dense gas clouds. Hiding beneath this blanket was an entire generation of unique, massive, but visually dim stars. Furthermore, spectral analysis showed that in the early universe, stars formed according to a completely different recipe. There were many more heavy, supermassive luminaires that quickly burned out and turned into black holes or neutron stars, or else an immense quantity of small, dim stars that simply didn't shine as brightly as astronomers were used to seeing. When researchers recalculated their models to account for this hidden factor, the puzzle finally came together. The galaxies weren't breaking the laws of physics. They were simply always much more massive than our instruments on the surface of Earth could see. Why is this discovery so important? First, it saves modern cosmology. We won't have to throw the laws of physics in the trash. Nature simply turned out to be much trickier than we thought. Second, it explains another great mystery. Why supermassive black hole monsters grew so rapidly in the centers of early galaxies. If the galaxies themselves possessed a much larger mass from the very beginning and contained colossal reserves of hidden fuel, then the black holes in their centers had plenty of material to grow at a frantic pace. We see that the early universe was far more turbulent, matter-rich, and productive than assumed just a few years ago. It was a true factory of cosmic giants. Every time it seems we have fully figured out the rules governing our world, the cosmos throws a new surprise our way. Hidden stars prove that countless mysteries still lurk in the darkness of the early universe, waiting to be discovered. The James Webb Space Telescope is only beginning its work, and shocking new findings lie ahead. And what do you think? Will we ever be able to peer even deeper through the dense dust? All the way to the very moment the first stars in history were born. Write your thoughts in the comments. Don't forget to subscribe to the Shocking Space Channel, like this video, and ring the bell so you don't miss upcoming episodes about the main mysteries of our universe. Thanks for watching, and remember, the cosmos is much vaster and stranger than it seems.